Okay, good morning, good afternoon, and good evening, wherever you are in the world. My name is Steve Lewis, and I'm a Senior Director of Risk Tech based in the UK. Apologies for the slightly late start. We had a few technical issues, so hopefully they're not going to repeat during the webinar. So fingers crossed on that one. But yeah, apologies again just for starting a little bit late. But thank you very much for joining us, and welcome to this webinar. This webinar is the second in our 6th series that we've run since May last year. Now, we regularly ask you what topics you'd like us to cover, and as a result, we're presenting during this series on 4 of the most popular requests. The second of those topics is the subject of today's webinar, which is about LOPA, Layer of Protection Assessment, and in particular, the relationship with HAZOP. So hopefully we can provide some useful and practical insights for you. The webinar is going to take about an hour, with around 45 minutes for the presentation and 50 minutes for the Q&A. A little bit of housekeeping: we've muted everybody, so the sound won't be distorted by background noise. And if you'd like to ask questions, and we really do encourage you to ask questions because they help to bring the webinar to life, then please use the Q&A function. I think most people will be familiar with Zoom, but if you're not, if you just sort of drag your cursor down to the bottom of your screen, you'll see that there's a little banner strip pops up at the bottom, and you see the Q&A button there. Just click that, type in your question, and I'll keep track of them, and we'll cover as many of them as we can at the end of the session and within the hour that we've got available. What I'd like to do now is briefly introduce Risk Tech to those of you who don't know us. Apologies to our regular participants who've heard this 101 times before. But what we do at Risk Tech is we help our clients to manage health, safety, security, environmental and business risk. And we do that in sectors where the impact of loss is high. We provide 5 types of services, sort of consulting services. So that's specialist risk management services. We also do online and classroom training, as well as postgraduate education to help develop competent risk professionals. We also provide associates to work at client locations where there's a resource or skill shortage. We also undertake industrial inspections and assessments in support of asset integrity and helping to mitigate project risks. And then we also undertake research and development in the field of risk and safety management. Okay, I'd now like to introduce our presenter today. I can see we are having a little bit of trouble with the speed that slides are moving on. This might be a little bit of a challenge for our speaker today, Mylan. We think we've got about a 30-second time lag for some reason that we just can't work out between when Mylan presses the cursor to move the slide on and when the slide actually changes and you see it. So please bear with Mylan as he does his presentation. He's got to guess about 30 seconds ahead of when he's going to finish. But anyway, Mylan's got the experience to do that. He's got over 10 years experience in the management and completion of projects within risk and safety management for both onshore and offshore oil and gas facilities. He's particularly experienced in the areas of safety cases, performance standards, verification schemes, and supporting company procedures. He's also facilitated a huge number of hazard identification studies, HAZOP studies, and LOPA, which of course is the topic today, as well as bow tie and matrix of permitted operations workshops. He's also done a lot of delivering a lot of training courses on a pretty broad range of topics such as risk assessment, asset integrity management, and bow tie assessment. Okay, so I'm going to hand over to Mylan now, and as I say, we might have to bear with us a little bit on the timing of the transition of the slides. Over to you, Mylan.
That's great, thank you, Steve. Yeah, as Steve said, my name is Mylan Dempsey. I'd just like to again give my welcome to everyone, and thanks for coming to this session. And what we're going to be looking at today is specifically around LOPA. The question being, if you've carried out a hazard identification exercise, such as a HAZOP, when might you need to do a LOPA? Why would you need to do a LOPA? And what would that LOPA look like? In addition to having a bit of a think about different other SIL assessments that there are in the industry that can be used, and when LOPA may or may not be the best of those assessments to use for the situation. So I just mentioned the word SIL assessment. So in terms of the question, what is a SIL assessment? Well, SIL stands for Safety Integrity Level. And essentially a SIL assessment is a methodology that you can use to ensure that the controls you have in place to manage a certain hazardous scenario that you've identified within your hazard identification exercise has a sufficient number and adequacy of controls, and key part being their independent controls in place to manage these scenarios, these hazard consequence scenarios, to a level which we may consider to be tolerable or a LOP. The primary objective of the assessment is to analyze these controls, considering them as layers of protection, which again, you'll see reflected in the name of LOPA, which is a layer of protection and analysis study. In terms of industry guidance you have and what's in place to kind of support you in understanding how these are carried out, when they're carried out, the two documents there, IEC 61508 and 61511, are really the two major documents within the industry that will provide guidance on that, and they're very large and very in-depth documents that are actually really rather good. So if there's any further information you are wanting on completion of this course, or you're wanting some bedtime reading, then those two documents there are a good starting point for that. You see there on the diagram on the right, we talked about the layers of protection there, and we'll certainly go into it in more detail when we talk about LOPA specifically, but you can see we have our varying layers of protection that we're using and assessing and defining when we can get from the tolerable risk, as represented from that orange line there, down to the residual risk, and reducing the risk associated with it, not only to a level that's tolerable, but ideally below that to a level we can consider to be a LOP. And you can see there are many different safeguards that can be considered, inherent process safety, process controls, alarms, all this sort of good stuff. One other key thing to note is that a SIL assessment isn't necessarily something you're going to carry out and never look at again. You may carry out various SIL assessments within the life cycle of a facility or an operation, and at different stages of the life cycle, these studies may have different aims and different objectives. If you're carrying it out for the first time, you may be looking to kind of standardize the controls you have in place and the assessment of them. And this could be the case if you're carrying out some sort of modification to the facility as well. If you're carrying it out later in the project, be it in the detailed design or during the operations, then it's going to be something more along the lines of assessing it with regards to verifying what you have in place is still correct and the effectiveness of all your controls is still justifies the assessments that you've carried out on them, and the benefit and the value that you've given to those controls is still applicable. So the key point there being that it's not necessarily a study you do once and you forget about because it's done. It's something that may need to be revisited and reviewed over the entire life cycle of the project, be that for changes or just to verify what's been done previously based on the current condition of the facility and the current nature of the operations being carried out. Hopefully the slides changed over, but essentially while we'll focus later on specifically on LOPA, there are many different methods you can actually carry out for SIL determination. And you can see here on the right-hand side, this is actually a diagram from IEC 61511, the document we referenced earlier, that we've annotated slightly. And essentially this visualizes some of the many different methodologies you can put in place with regards to what is the complexity of the studies required and what level of conservatism they have. So you can see right at the top left-hand side there, we've got quantitative, risk assessments or quantified risk assessments. Now, these are going to be the most complex studies you can carry out, but they're also going to be the most realistic and accurate. The level of effort you're going to put into them is going to be far larger, but you're going to get a very good idea of the specific risks associated with each individual SIL loop and each individual part of the process in carrying that out. As we work our way down to the right, you can see fault tree analysis is one of the other studies we can do, and this is also a fairly complex and a fairly in-depth study methodology for SIL determination. And working our way down, we have complex and simple LOPAs, with complex LOPAs being the more complicated of the bunch, and we'll go into a little bit later the difference between the complex LOPA and the simple LOPA and the use of orders of magnitude. And at the bottom there, you can see the most qualitative is going to be something like a risk graph, which is quite a quick methodology to carry out. It's quite easy to do compared to the other ones and requires less effort. The other thing I haven't talked about hugely, and you'll see it on the bottom axis of the graph there, is increasing conservatism. Because we work in safety, and because this methodology is a safety type of assessment, inherently the more simple the methodology becomes, the more conservative it becomes. So we don't allow ourselves, if we're simplifying it, to underestimate the risk. So what you'll find is that if you are carrying out one of these simpler methodologies, it is inherently going to be more conservative and is going to give you more stringent requirements when you come to defining your controls, because of the inherent nature of how the methodology is carried out. The last one on the bullet points there, you see I hadn't mentioned it yet, is a human reliability assessment. Now, human reliability assessments do fall within this line, but obviously they're more focused on human error, human reliabilities, and the activities and operations carried out. Whereas most SIL assessments are typically more concerned with actual systems and equipment, so programmable, electronic programmable systems, so EEPE. However, LOPA kind of sits in the middle of that, if you will. So LOPA will obviously consider all of your EEPE equipment, but it will also take account of and consider other different types of safeguards that are passive systems, mechanical systems, even certain operator actions and activities, given the right conditions, can be considered and defined within the LOPA methodology as well. So when you're looking at the requirement to do a SIL assessment, it's not simply a case of looking at it and saying, okay, we're going to do a LOPA on this. The initial stage is really going to be looking at all the different types of SIL assessments and considering which one of these is the most appropriate for this operation, given the nature of the operations, the nature of your organization, the level of the risks that are being considered, and understanding and keeping in mind that if we do actually go simpler in how we apply our methodology and which methodology we choose, we will end up with a more conservative answer, which will inherently put more stringent requirements on us at the back end and the output of the assessment, requiring us to define a higher SIL level to the safeguards that we may have in place. So, specifically regarding LOPA, which is going to be the primary focus for this webinar we're doing here, LOPA is essentially a semi-quantitative tool for managing risk using numerical methods, but also a qualitative rule-based structure in applying them. Now, anyone who's been in presentations about risk assessments or discussed risk or is involved in the industry of safety is probably well aware of the Swiss cheese barrier model, which we like very much within the safety industry. And it's actually also a very good analogy of LOPA and layers of protection, where essentially the Swiss cheese, each of the blocks of Swiss cheese, if you will, represent a barrier, and the holes within the Swiss cheese represent the inherent means by which those barriers will fail. And essentially what we're doing with LOPA is we're analyzing each of those blocks of Swiss cheese and the specific locations of the holes within that cheese to make sure that there is no common mode failure, or there is no potential pathway that we could line up all the holes and get straight from what could be considered as a cause to a consequence that could result in people, environment, asset, or reputation damage. Another analogy that is used quite often for LOPA, and you'll see it on the right hand side, is the onion. So you'll see here a figure that represents an onion, and there are a lot of different layers of control. And the center there, you've got control and monitoring. So you've got your process systems, your alarms, supervision of operators, prevention with mechanical protection systems such as relief valves or specific safety instrumentation systems, mitigation systems as well. You can have emergency response. So obviously at this point, we've actually gone past preventing the actual cause, but rather mitigating the consequence. And finally, community emergency response. So this could be if you're an onshore facility or an offshore facility coordinating some sort of response to an environmental spill, let's say. So in terms of high level of how we actually do LOPA and what we actually do, we use data estimates of initiating events and data estimates of the effectiveness of our independent protective layers or our controls that we have in place to assess what the overall risk is and comparing that to some level of tolerable value, which may be defined by industry or a company specific value or based on best practice. Essentially, what we're doing is we're answering the three questions you can see on the screen there. How safe is safe enough? So again, what is our level? What is the level that we're trying to get the risk down to? How many protection layers do we actually need to get to that level? And how much risk reduction should each protection layer provide? So those bottom two there are quite inherently linked. It may be that the protection layer needs to be more robust, or it may be that we need additional protection layers if we cannot make that layer more robust. The key thing, and one of the main topics of this slide, as I'm sure you'll have guessed by the title, is that the LOPA is going to take the safeguards from the HAZOP and the consequence from the HAZOP, and it's going to use them inherently within the methodology it carries out. So what you'll find is the causes, the consequences rather, and the safeguards from the HAZOP, which are outputs from that study, are the inputs into the LOPA, which we'll use then and take them forth into the study. Now, I talked a little bit earlier about simple LOPA and complex LOPA. Now, in the second bullet point there, we've got data estimates that we're using, and that could be for event frequencies and effectiveness of barriers. A simple LOPA will tend to use orders of magnitude to estimate these frequencies, so 10 to the -3 or 10 to the -4. Sometimes going into a little bit more detail, maybe 5 or 2.5 times 10 to the -4. Whereas a complex LOPA will inherently use more detailed data and will also maybe incorporate additional considerations into this calculations. We call these conditional modifiers within the LOPA methodology. So there may be things such as ignition factors for probabilities of ignition in specific areas, occupancy factors to assess the specific likelihood of fatalities or impacts to personnel, again, within specific areas or from specific systems. Even things such as weather modifiers based on prevailing winds and general weather information from the area to incorporate these into the into the inherent LOPA methodology. And while I refer to these two methods as complex LOPA and simple LOPA, while they are often defined separately, sometimes you'll find that what is mostly a simple LOPA may incorporate one or two elements from a more complex LOPA. So it's not a hard and fast rule for the most part that defines both of those, although often it is stated when you're setting out to carry out a LOPA which one you're going to aim for and which one you're going to try and do. I'm just going to give it 10 seconds before I move on to talking about the next slide, just to make sure it's on the screen.
No, that's on the slide.
Excellent.
Sorry, that's on the screen.
Thank you. Yeah. So one of the main questions we're going to be discussing in this webinar, and you see here on the slide, is when is a SIL assessment actually required? So unfortunately for everyone, there isn't a hard and fast rule or a single regulation that exists in the world that says if it's this specific condition, you will carry out a SIL assessment. There are a few different factors, the three primary ones being industry best practice, the specific rules of the company or organization you work in or even work for, be they your clients or your company yourself, and specific regulator expectations, which will vary from region to region and around the world. Within the UK, at least, usually you'll find the regulator tends to be more goal setting. They'll never say you have to complete this specific study, but more often than not, there'll be an expectation by the regulator that, oh, I would have expected you to carry this out. And essentially it comes down to ensuring that you are content and you are happy that you have properly assessed the controls you have in place. And you tend to find that industry best practice does drive SIL assessment to be carried out within many of the different regions around the world. Now, I say this, but you're only going to carry out SIL assessment against certain hazard consequence scenarios. And these are going to be the hazard consequence scenarios that generate a significant safety consequence. So within your hazard identification exercise, this is inherently going to drive you to doing some form of risk ranking. Now you can see on the right-hand side, we've got a risk matrix there. Now this is just a generic risk matrix, but based on the organization that you may be in, that has defined their risk assessment procedure, that has a specific risk matrix and associated definitions of what a catastrophic consequence is or what highly likely with regards to likelihood might mean, will drive you towards giving certain hazards and certain hazard consequence scenarios a specific risk ranking. Now, the other aspect to this is defining what is meant by a significant safety consequence. So often you'll find with LOPA that the consequence in and of itself, in terms of the ranking, will drive what is LOPA'd, but it may also be with regards to the overall risk ranking. So you can see in this one, we've highlighted the catastrophic consequence in a bold box there. Maybe we say anything that falls under catastrophic, we're going to carry out a SIL assessment against. It may also be that you decide anything that falls within the red risk ranking or the catastrophic consequence, we're going to carry out a LOPA against. And that is going to be highly situational based on what the definitions within the risk matrix you're using are for catastrophic or serious. And in this example, this risk matrix is a 5x5 matrix. You may have an 8x8 matrix, and you may need multiple levels of consequence to assess and carry out. So there's a whole range of things that it's never going to be one size fits all, if you will. And when we're carrying out this SIL assessment against these hazardous consequence scenarios, we will essentially, what we're doing is we're providing a logical method for defining what the independent protection layers are that will either reduce the frequency of an event occurring or even remove it. or mitigate against the consequences that are generated from that event. So what we're going to do next is we're actually going to go through the LOPA process step by step at a high level, just to kind of give you an idea of what's involved and how you will actually carry that out. So I'm just going to put another 5-10 second pause in just to make sure the slide is come over.
Yeah, it's come through, Marlon. It does seem to be speeding up now. It seems to have fixed itself. Yeah.
Excellent. So we've for the purposes of this, we've split the process down to 11 steps. This slide covers steps 1 to 6 of the LOPA process. And the first step there is something that may already be done. It may have been done by the company at a high level, but it's defining what your targeted mitigated effect level is. Essentially, what we're saying is, what is the level of risk that we're aiming for, so we can take that forward as a benchmark when we're actually carrying out our LOPA study. So once we've got that, and I said that in many larger companies will already be defined in a procedure or a process somewhere, and it may just be confirming that. If this isn't something that is available or something that you have to hand, you may have to define it. There's many areas of data or suggestions. You have documents from the UK HAZOP, like the Process Safety Leadership Group, that'll have specific suggestions for it. And often you'll find this TMEL, as it's called, will be different for employees and members of the public as well. So especially for onshore facilities, it may be that the TMEL will actually be more stringent on members of the public than it will be for the specific employees as well. So once we've got this, we will have a look at our hazard identification, whatever we've carried out. We'll have a look through the risk ranking, and we'll pull over the cause consequence pairs. So what consequences we've ranked, however we've defined that, be that the highest level consequence or anything within the red zone of our risk matrix, and we'll pull them forward to carry out a LOPA on them going forward. So again, that's another thing that is going to be dependent on the HAZOP that we're going to bring into the LOPA, as is the number 3 as well, identifying what the initiating event or cause is. So again, it's going to be the cause that's coming from the HAZOP. Now, number 4, we need to define what the actual initiating event frequency is. So we have to provide a number, a numerical definition, if you will, for the initiating event. Now, again, as I'd said above for point 1, there's many different industry documents and industry guidance documents that are out there where you can pull data from there and define that. One of the issues you'll find is quite often for certain aspects that one document might not have everything you need. So you may be taking it from 1 or 2 different places for that as well. But there's guidance, industry guidance, there's guidance from bodies like the UK HAZOP as well, within the UK side of it. But once we've got that, then we've got our TMEL and we've got our initiating event frequency. After that, we're going to identify our available safeguards. And again, if we've got a well-written HAZOP or a well-written hazard identification exercise, we should have most, if not all, our safeguards already identified, so we can pull them across. It's number 6 is probably the most interesting part of the first half of these steps, and that's identifying and defining which of these safeguards qualify as independent protection layers. So I've talked about this a few times already, but essentially an independent protection layer is a control that we have that is auditable. So essentially we can verify that it is there, it's tested, it's maintained. We've got the records for it. So if we're talking about a relief valve or a trip that we do maintenance on it, we've done testing on it, we can confirm and audit and verify that it does indeed work, that it's effective, so that the whatever the safeguard is a reasonable safeguard, and it is actually going to control against the risk we're talking about. Another good example of this one is if we're claiming like a relief valve, the relief valve has to be suitably sized and rated for the consequence we're talking about. Otherwise, it's not actually an effective control. And independent. Now, this is one that's a common tripping point, but is it truly independent? Now, when I say this, is it independent from the cause and consequence itself? And is it independent from the other safeguards we are claiming? So if we're claiming two, let's say, control valves, but they share the same control system, they may not be truly independent, as the control system may have a common mode failure, which will cause both of them to not function. So we would only be able to claim one of them. So that is the one of the common areas that you trip up on, or that can be tripped up on, is assessing the safeguards and actually identifying which of these are truly independent. There is a book called CCPS LOPA that has quite a lot of good information on independent layers, if anyone's wanting further information on that. And you can see here that the 2, 3, and 5 within these steps are actually all taken from the hazard identification exercise, or the HAZOP, or whatever we've done to implement into the LOPA. So having a good HAZOP and having a good input to it is going to make our lives a lot easier when we get to this stage of the process. But we will talk about that a little bit later on. So the next few stages that we'll discuss, so we say steps in the LOPA part 2 of 2. You can see here, actually, we've got on the right-hand side the a visual representation, the upside-down triangle. And you can see here the unmitigated process risk. So that is our TMEL. And we've got down here the target mitigated event likelihood, that is our TMEL. And the unmitigated process risk here we've got as our initiating cause frequency. And what we need to do within this process is obviously get down from that red dotted line down to the green line here. So now we're at the stage, we've identified our safeguards, and we've defined which of these are truly independent protective layers. So for these, we need to assign a probability of failure on demand. So any barrier we put in place is never going to be 100% effective. So we need to be able to define what is the probability this barrier will actually fail on demand. So some IPLs, independent protective layers, may have a very low probability of failure on demand, and some of them may have higher probability of failure on demands. And this is also information you're going to be getting from guidance. So you can see in the LOPA process, there's a lot of data we have to pull in from historical data and industry guidance, and a lot of information from these sources. Sources such as layers of protection analysis within from the Center of Chemical Process Safety, among many others, to be honest. So once we've defined this, and for each of our safeguards, we understand what the probability of failure on demand is, we can then start to think about what those safeguards are actually doing for us, and how much are they truly protecting us against that unmitigated process risk. What is the benefit we're getting from them, and how much are we reducing the risk from a quantitative value, taking account if we are applying them indeed of conditional modifiers that we talked about in the complex LOPA. Maybe we're applying things such as ignition probabilities or occupancy factors, and taking account of our preventative and mitigative independent protection layers. And we'll end up with a level that we're at, and the result based on our current safeguards in place. Now, in the example animation here, you can see, well, we haven't quite got to the part where we're at our target mitigated event likelihood. So in this scenario, we need to then have a bit of a think. What are the safeguards we can put in place? We need to raise a recommendation. Now, this recommendation could come in the form of improving our existing safeguards. How can we make them more reliable? How can we actually allow them to provide us with a larger risk reduction? Or it may be we need additional layers. So we need additional safeguards to be put in place and additional safeguards to improve our risk, to get it down to, at the very least, the target mitigated event likelihood. So in this scenario, we'd be going through the workshop and we'd be raising some recommendations. One thing to note is that just because we've hit our TMEL doesn't necessarily mean we should stop trying to improve our system and trying to make it as low risk as possible. But from a pure methodology perspective, from the LOPA, that is the point at which we've achieved our goal, if you will, for the methodology. So if you are not at your TMEL, you do have to raise recommendations and you do have to identify additional safeguards. So we've talked a lot already about the HAZOP feeding into the LOPA. Now I say a HAZOP, it's usually a HAZOP in most cases. It could be a different form, like a what if assessment or some other hazard identification assessment, but it's typically a HAZOP. And having a good quality HAZOP or a good quality document to feed into the LOPA in terms of the input can actually provide us with a huge benefit and make our lives a lot easier within LOPA for a minimal increased effort within the HAZOP. So thinking about whether you need LOPA ahead of time and structuring the HAZOP to allow yourself to best do it will save you a lot of time and effort in the long run. Some of the key things you can take from a good HAZOP is defining very clearly what your initiating causes are, what your consequence is, and making sure you're taking that consequence to the end level and defining exactly what you need for that consequence to occur. So what conditions do you need? For instance, ignition, if we're talking an ignited event, the presence of people, is it going to cause a fatality, multiple fatalities? And again, you can go off your risk matrix as well and help you with the risk ranking to allow you to specifically define it. So if you've got a specific risk ranking for 5+ fatalities, capturing that within the consequence is not only going to help you in the HAZOP, it'll help you going forward in the LOPA as well. And again, yeah, it's referred to below, but consequence severity, specifically defining what the consequence is. Again, it's not just for people, but for asset, for environment, and if you have reputation, for reputation as well. And making sure your safeguards are detailed and also specific to the consequence that it is actually put against as well. So essentially, your LOPA, it starts at the consequence. It'll have some input from the cause, but realistically, it starts at the consequence, whereas your HAZOP or hazard identification study will start right at the beginning with the cause or the deviation if you're using guide words. This last slide here that we've got is just some of our experience, some kind of typical or potential issues you may have with LOPA, or you may have with HAZOP that can cause issues within LOPA. Vague causes is a common one. So if the HAZOP has captured increased pressure as a cause, that's not you're not easily going to be able to define what the frequency of that initiating event is, because increased pressure could come from many different scenarios, and especially if you've got a situation where the team carrying out the LOPA is slightly different from the team carrying out the HAZOP. Perhaps someone is unavailable or has carried out one and someone else is carrying out the other, then that's going to be a problem for the people carrying out the LOPA, because they're not going to be able to define that very well, if at all. Independent causes not being split up is another very common one. So if the cause is a valve error in a HAZOP, in a HAZOP scenario, that makes sense. It may not be the best captured or the most detailed, but it still makes sense. However, from a LOPA perspective, for us to define what that valve error is, we need to know specifically what the initiating cause is. Is it a valve operated inadvertently due to a human error? Is it a valve failure due to a control system failure? Is it a mechanical failure within the valve? All of these different things are going to have very different initiating events, frequencies, because they have fundamentally different frequencies and methods in which they may fail. Inadequately defined consequences. So a loss of containment is a consequence, and that may very well be right, but we need to make sure we're taking the consequence through to the end scenario, to the end of the timeline, if you will. So is the consequence going to be loss of containment leading to an environmental spill, causing adverse environmental impacts? Is it going to be a loss of containment which might ignite and cause multiple fatalities within the Wellbay area, let's say? So making sure our consequences are very clearly defined is going to help us immensely within the LOPA process. Falsely claiming non-independent barriers. Now, this is one that is fairly easily rectified within the LOPA and not really a huge concern if it does happen, because it's going to be one of our steps. But claiming barriers that are controlled by the same control system, or actions or activities that are carried out by the same person, we will have to make sure that we're not carrying both of them forward for the LOPA. And if they are reflective of, and they are effective barriers rather, then we can claim one of them, but not both. And I suppose that comes down to the last one as well, inappropriate barriers being claimed. So claiming just, oh, there's an alarm, that's not an effective barrier in and of itself. It's an alarm in and of itself will do nothing. It's the operator response in combination of the alarm informing him of an issue or them of an issue that is the main control there, and making sure that those barriers there of not only a fully defined barrier, but it's a barrier that's effective. So is the operator, whoever they may be, trying to do 10 things at the same time? They have 2 minutes to carry out 2 5-minute tasks. That's not inherently going to be an effective barrier. And finally, just some general LOPA issues at the bottom here. So obviously LOPA is one of many different assessments, both within the bracket of SIL assessment and within the wider bracket of risk assessment as well. So there are many benefits, but there are also some pitfalls and some things that it's not going to be able to cover. The first one is that obviously within the LOPA assessment, we're focusing on one cause consequence pair at a time. So this may inherently cause us to miss some complex interactions between different consequences or between risks and controls. So it's something to be aware of. Sometimes the quantification of risks, obviously we're taking it from different data sources. It tends to be based on historical data. They may not fully allow us to account for any common cause failures. Anytime we start to get into the complex side of the LOPA as well, we start to incorporate our conditional modifiers rather. We start to stray into QRA territory, and often a quantitative risk assessment then sometimes becomes a better method than a SIL assessment in and of itself. Sometimes human error can be a bit of an issue in defining. There are many different data sources that can be used and are used for defining human error within a SIL assessment, but often a more detailed assessment, sometimes going back to a human factors assessment, or as we discussed earlier on, might actually be a better option for that. And I guess the last one, and we've touched on it a few times above, but we do inherently rely on fairly generic data. Sometimes if you've got a lot of historical data within a larger company, they may have their own data, but to be able to carry out the method, we have to use historical data to understand what the initiating event frequencies are and what the probability of failures of demand are. So we are inherently relying on data which is fairly generic and required to have been truly quoted and truly reported by all different operators who may have used that valve, whether they did truly report it or not. So whilst LOPA is a very, very useful methodology within the overall risk assessment and within SIL assessment, it's not without one or two flaws as well. So it's in understanding SIL assessment and understanding the different types that we can select it where it's appropriate and go within the LOPA methodology itself, go into the correct level of complexity to ensure we're getting the correct, applying the correct level of assessment to our operations and our hazard consequence scenarios. So just as an overview here, LOPA is a semi-quantitative tool which may be used to assess the adequacy of the layers of protection or layers of control in place. It's one of many different SIL assessment scenarios which may be implemented. And within LOPA itself, we're going to have more simple or complex LOPAs, or as is appropriate. Whether or not we should carry out LOPA should be based on judgment, the judgment of competent people such as yourselves, taking consideration of industry and company best guidance, industry best practice, and should only be applied inherently to our high severity hazard consequence scenarios, whatever definition we may have given that within the company or based on best practice. And finally, an effective LOPA will require an effective and a high quality hazard identification study as an input, such as a HAZOP. Alternatively, LOPA will become far more onerous and may even become impossible depending on the quality of that input that you have in place. So thank you everyone for your attention today. I think we're going to move on now to the question and answer section of the webinar. So I believe, Galina, have you been collating the questions?
Yeah, no, I'll pick that
Steve.
up, Mylan. Yeah, no worries. Yeah, so yeah, thanks very much. Very well done. I know it's very tricky when we have this sort of lag issue, which we've not had before, but there you go. So well done. Okay, so there's a number of questions that have come through. The first question from Iade. Sorry if I've butchered your name there. Which did make me think we probably should have put a warning right at the start of, beware lots of acronyms ahead, because there does seem to be an excessive number of acronyms in this part of the risk assessment world. So I think he's just looking for a little bit of guidance or thoughts on the difference between PHA, so sort of process hazards analysis, in the context of the sort of US terminology, I think, versus HAZOP, versus LOPA, versus SIL.
Yeah.
Can you say anything about
yeah, sure.
Just quickly, yeah.
So I think you could consider PSA and HAZOP are both going to be your hazard identification exercises, where you run through your process systems to assess what are the potential causes of safety or operability issues, what are the consequences of that, and what safeguards I have in place. Though either one of those two studies, you will then look at and, as we said, pull out what we consider to be the high level or the worst case hazard consequence scenarios, and that will then subsequently feed into a SIL assessment. So LOPA is one of many different SIL assessments we can use. It's probably the most common one of the bunch. And the SIL assessment takes the input from those high severity hazard consequence scenarios and then allows us to specifically assess the adequacy of the layers of controls or layers of protection for each of those scenarios.
Okay, great. I've got a sort of two-part clarification comment from Michael, and I think it makes a really good point here, which actually you did pick up later in the presentation. There is a slight difference in approach here, whether we're doing a LOPA to support a SIL assessment for a safety instrumented function, or just doing a LOPA for all scenarios.
Yeah.
So perhaps more specifically, so if we do a LOPA triggered by the consequence severity, as you discussed, then that ensures that all valid scenarios identified in the HAZOP are assessed to ensure that the IPLs are enough to reach the target mitigated event likelihood.
Yeah.
And of course, there may or may not be a safety instrumented function associated with all of those scenarios. He also makes the second part of his point is that if we just focus on SIL, then we will omit a number of scenarios that don't have a SIF associated with them. And that, so perhaps only, I don't know, maybe 2/3 of the scenarios do have a SIF associated with them. Have you got I guess it's just the purpose of the LOPA
yeah, no, that is a fair point, and one of the clarification, I guess, is if you're using the hazard identification exercise and pulling out your high severity consequences, there may be some of those consequences that are not actually appropriate to carry out a SIL assessment on. If you look at some of maybe the drilling exercises, the drilling activities that are carried out in the North Sea, and it's something to do with a specific operation or an activity that's carried out, you may look at that and say, well, actually, it's more of a human activity where certain actions are being taken, and maybe some of the specific systems can be subject to that, but there may be certain activities that SIL assessment is not appropriate, and that might be where you look at the human activity, the human assessment or human factors assessment or a safety critical task analysis. There may be other scenarios as well. If you have a cause that is resultant from something like corrosion or something like that, where realistically you're maybe not going to be able to carry that forward into a LOPA if that's the one you're looking at, because it's going to be an initiating event that you're not really truly going to be able to define. And it may be that you identified as one of your high severity ones, but SIL assessment is not the method to take that forward for investigation management. So no, that's a good point that was raised.
Yeah, thanks for the clarification on that. Question from Ali. You did mention the CCPS, so the US Chemical Center for Process Safety guidelines for LOPA. They've also got guidelines for process safety management and a raft of other process safety related topics. But is there any guidelines from the UK for LOPA or process safety management?
So to be honest, the two primary documents are going to be the IECs, the IEC documents that are referred back, 61511 and 61508. They're the two kind of main documents that kind of get referred to by the UK HSE. The UK HSE does have some kind of technical notes. They tend to produce kind of technical notes on that they'll have on various aspects of SIL assessment and LOPA as well. Okay.
And just for clarification, 61508 is the generic document, and 511 is the process industries document. Is that correct?
Yes, that is correct. Yeah, 61511 is specific to the process industry sector.
Yeah. A question from Hardeep. LOPA and SIL assessment are carried out for instrumented function. Is this approach also suitable for a hydraulic system, for example, a hydraulic wellhead control panels?
Sorry, I was on mute there. Could you repeat that question?
Yeah, sure. So is LOPA and SIL, is that approach suitable for hydraulic systems? So for example, a hydraulic wellhead control panel, or would we use a different technique for something like that?
Yes, so the SIL rating, as it were, is tends to be something you'll apply to the actual electronic systems, as it were. But you can apply the principles of the methodology to a hydraulic system, certainly.
Okay, a question from Chioke. A common pitfall in LOPA is taking credit for two dissimilar check valves as an IPL to prevent overpressure due to reverse flow.
Yeah.
Do you have a view on that? Do you have a take on that?
So did you say, sorry, two similar or dissimilar?
Two dissimilar check valves.
Yeah, within LOPA, for the check valves, if you're wanting to capture them as a independent layer, it has to be two dissimilar check valves. That's correct.
Okay. Okay, a question from Kaylee. When setting out the scope of a LOPA, should you consider all possible initiating causes of an end consequence? So for example, for a plant fire, could we consider heater failure and other process failures on the same LOPA? Or do we just stick with this sort of one cause consequence pair, as the other initiating cause may require different IPLs?
Yeah, so it's an interesting one, that. So I guess it comes down to how you've done your HAZOP or your hazard identification exercise, and if the causes have been inherently split in there. If you're going to be carrying out a LOPA, I would suggest making sure you have all your causes independent. Well, you have to have that inherently, but I would recommend they be independent at the actual HAZOP stage or hazard identification stage rather than at the LOPA stage. But yes, you would have to consider all of the specific causes. But the reason it's beneficial to do that at the HAZOP stage is that when you're carrying out the risk ranking, you may find that some of those causes are not actually hitting whatever risk ranking criteria you require to actually bring it forward to the LOPA.
Okay, thank you. We'll take three more questions. Question from Ali. Do you have any idea why the CCPS guidance requires at least 100-fold risk reduction for an IPL? I must admit, I'm not quite sure it treats it like that, but maybe you know more.
No, I'm not certain of that one, to be honest.
No, I'm not sure that's quite the right interpretation of what's required, but I may be wrong. Okay, question from Choki. Again, talking about taking credit for recommendations. So do we take credit for the recommendations or additional IPL as part of the LOPA? I mean, do you include the PFD from the recommendation in your assessment?
Yeah, so it's the way I like to do it is I like to say, so to that the PFD is what it is, but then demonstrate at the bottom of that with the implementation of recommendations X, Y, and Z, this will bring down the level to the TMEL or below the TMEL or whatever level it's going to bring down at. So I like to quote it as it is, but with the caveat of with the implementation of all of these recommendations, we get it to below that.
Thank you. And then the final question from Eric, also related to probability of failure data, and I guess this could include initiating event causes, initiating event frequencies, probability of failure on demand of hardware equipment or operator errors. I mean, where do you get this data from? I mean, say you haven't had any historical events.
Yes, the data is going to be from, there's a whole range of data and it's available. You tend to find that different industries will have different sources that are appropriate for them, though there will be generic sources for it as well. I guess without further industry specific stuff.
Yeah.
couldn't really guide it. But yeah, there's a whole range of sources that you can find online and within specific journals and publications.
Yeah, I think the important thing is to make sure we're using the authoritative sources.
Yeah, and ensuring that
data.
the data you're taking it from is the most appropriate for whatever industry and whatever context your facility or operation may be applicable to.
Okay, Mylan, thank you very much. We're just over the hour there, so we'll wrap up now. We will make a recording available to everybody probably early next week now. When you leave the webinar, you should automatically receive a survey in your browser. It literally only takes 30 seconds or so to complete it, and we do appreciate your feedback, particularly if you have any ideas for what you'd like us to talk about in the future. If you've got any questions arising from what you heard today, or you'd like any information about any of our services, then please simply email us directly. If Mylan advances the screen, there's a general inquiries email address there. I think early in the presentation, Mylan had his email address. You could use that, or you could just go to our website, and literally on every page of the website, there's a form which you can fill in to get in contact with us, and we will get back to you. So thank you, Mylan, once again. Thank you, everyone, for your attention. Really grateful for you taking the time out of your busy schedules to listen in today. The next webinar is next Wednesday, so that's Wednesday the 15th. It's at 3 p.m. UK time, and it's about cybersecurity of operational technology. Right, okay, that sounds interesting. I'm looking forward to that one. So hopefully you can join us for that one. In the meantime, please stay safe and stay secure, and enjoy the rest of your day. Goodbye.
Thank you, everyone. Bye.